Welcome, class. Today we will be talking about how to prove segments, statements about segments, and angles. This is the time of year where people learn about proofs, and you've already had a little bit of having to justify your steps, but this goes another level up, and people, this is usually where they start to either love it or hate it. Hopefully it's the former, not the latter, for us. The very first thing that we need to talk about is something called congruence of segments or congruence of angles. This is theorem 2.1 and 2.2. Alright, Mr. H, what question do you have for us now?
Alright, you gotta help me out. I don't have any idea what a theorem is. I might know what a postulate is at this point, but a theorem, what is a theorem?
That's actually a great question. Theorems are just like postulates, except for I could actually prove that theorem 2.1 and 2.2 have to happen. Postulates we just had to accept before, but theorems I can prove. So, the reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence. These three are the three that we talked about last time. They're also the ones down here. Except for now, instead of equality, it's of congruence. So segment AB is congruent to itself. It's the same size and shape as itself. Just like angle A is the same size and shape as itself. The symmetric property, remember, allows us to flip it around. So segment AB is congruent to segment CD. Then it's also segment CD is congruent to segment AB. Same thing for angles. That's where this OR part comes in. And then last but not least, the transitive property, that's getting rid of the middle nominal. Segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So let's get rid of that segment CD and just cut right to the chase. Segment AB is congruent to segment EF. All these ones dealing with segments are the ones that is under theorem 2.1, and theorem 2.2 is all the ones dealing with the angles. Alright, so use a two-column proof to show that segment AC is congruent to segment BD. Also in this picture here, I see that it's labeled as segment AB being congruent to segment CD. Those two things I know to be true. So in a two-column proof, we first of all make two columns. So I split it down the middle with this. I have the left column be called statements. I have the right column be called reasons. And underneath it, I put each step with a number for it. The first step is always writing what is given. If it's marked in the diagram, if it's said up in the upper part here, I would put it here. So length of segment AB is equal to length of segment CD. And that's given. That's something I can look in my diagram, I see it. You could make an argument that before this step I should really say segment AB is congruent to segment CD. Valid point, and then the next step would be this one and saying definition of congruence. But this is where I'm going to start for this one. For the next step, what do you think it is, Mr. Hottenstein?
You've already got the given, and I don't see how to modify the given any further. So I would go with what if we add two of the smaller segments to be the larger? I mean, that's something that I don't need to have up above to be able to do. Because I think that ended up being a postulate, so that allows me to do something like that even without further support.
Very good, yeah. When we don't have any information on here, the very first thing that we should probably do is get more information. I look over here and see that segment AC is this long one, and just like Mr. Hottenstein had said, I think we should probably do segment addition postulate where appropriate. So segment AB plus length of segment AB plus length of segment BC has to equal the length of segment AC. And the reason I chose that one is because that's one of the things I'm trying to show. So I could also do the same thing for length of segment BD. So first thing, length of segment AC is equal to length of segment AB plus length of segment BC, and that is a segment addition postulate. That's what allows me to say it. So that's where I give my reason. Same thing with length of segment BD, same reason. I'm using the segment addition postulate to get some stuff to work with here. Now, if I'm trying to show that these two are congruent, it might be beneficial to show that their lengths are equal. To do that, I would have to somehow change one of these to be such that it's going to be the same thing. If I have the length of segment AB equal to the length of segment CD, why don't I substitute in, for length of segment CD here, length of segment AB? So the only thing I have changed from here to here is that I have changed what I have here. It's still the same exact thing. So if I've replaced it, it's substitution. Now that I have length of segment AC equals this part here, and then I have over here that same stuff equaling the length of segment BD, why don't I get rid of that glob that's the same and just get straight to the point? Length of segment AC equals length of segment BD. Yeah, that's a true statement. I cut out the middle part, so if I cut out the middle part, that's just like the law of syllogism, or as we know it, the transitive property. And last but not least, I have their lengths being equal, so that means the segments are congruent. I say that. I forgot it again. Much better. Length of segment AC is congruent to the length of segment BD. And that is definition of congruence. I've just done our first proof. 2-column proof. It's like what we did before in section 5, where we have decided to give our reasons. But this is just a formal proof. The first step matches up to the first reason. So that first, what allows me to say the first thing is that it's given. What allows me to say the second and third thing is just a postulate that we have learned in the past. This is an important one. You might want to memorize it because you will use it just a little bit. Okay? Good. Name the property illustrated by the statement. I could also ask you, instead of doing a proof, what property is this? Well, if angle F is congruent to angle G, and angle G is congruent to angle H, well, angle G is congruent to two different things. So let's get rid of angle G and get straight to the point. Angle F is congruent to angle H. This is transitive property of congruence. Part 2. If segment EF is congruent to segment GH, then segment GH is congruent to segment EF. Symmetric. And then the last one, if I have it congruent to itself, it's always reflexive. Alright, so in example 3 here, I realize it says example 1, my bad. Prove that length of segment AB is equal to twice the length of segment AM. You know that M is the midpoint of segment AB. So when I look at this shape here, the only thing I can say for sure is this part right here. M is a midpoint of segment AB, given. At this point, I can either try to manipulate what I already have, or go again with pulling out the segment addition postulate, angle addition postulate to give me more to work with. Right now, I know I can say something about M is the midpoint of segment AB. And that is, segment AM is congruent to segment MB. And that is because that's what it means to be a midpoint. If M's a midpoint, it divides into two congruent segments. That's the definition of a midpoint. Well, if the segments are congruent, that means their lengths are equal. That's again just the definition of congruence. If they're congruent, lengths are equal, vice versa. At this point, I've kind of hit a wall. I can't really manipulate or change what I have there anymore. So let's just pull out that segment addition postulate to give me something more to work with. Again, the segment addition postulate is the length of segment AB, the full length, is equal to the length of segment AM plus the length of segment of MB. There we go. And that is, again, the segment addition postulate. Now that I have something more to work with, I'm trying to show that the length of segment AB is equal to 2 times the length of segment AM. What if I would replace this length of segment MB with this length of segment AM? I can do that. That's replacing, that's substitution. So, the only thing I changed from 4 to 5, where's my mouse, is that this here is the length of segment AM. So, that's the substitution property. And I look at this, if I add these two together, I get the length of segment AB equaling twice the length of segment AM. I just can add them together, combine like terms, and that's a simplify step. This is yet another proof that we have done. The basic gist of doing a proof is that you always start with the given, You work as far as you can get. And as soon as you can't get any further, you might have to add in stuff from the segment addition postulate, from angle addition postulate, stuff that you see in the diagram that isn't necessarily stated, or stuff that we get from our postulates. And this is one of the big things you need to be able to do, is decide when to pull out that segment addition postulate. Sometimes you won't use it. Sometimes you'll use it a lot. Alright, you should be able to prove a few types of segments, and you should get the basic format of a two-column proof. I know I didn't do any examples of an angle. However, it's the same thing, just it looks like an angle instead of a segment. Till next time.